In this problem, I hope to show you how to calculate the effective rate of a bank account, also known as the actual percentage yield, if you're given the nominal rate, or the APR, is 5.5% and the money is being compounded quarterly. To understand the contents of this video, I'm assuming you know a few basic things. First of all, hopefully your instructor has gone over the fact that an exponential equation can be traditionally written in the form of y equals ab to the x, where b is considered to be your growth factor. B can be used to find the percent change. So if x is in years and b was 1.136, this would mean that whatever you're studying, in my example money, would be growing 13.6%. In this specific example, a lot of students like to just subtract 1 on the b value and move the decimal over twice, and it would be 13.6%. That works for this specific example. The other thing I'm hoping you know is if you ever have a base raised to an exponent and then that thing is raised to an exponent, that you could simplify by multiplying the two exponents together. Hopefully if you understand that, you'll follow my logic here. What I'm going to do is take the compound interest formula that you're given from when you put money in a bank account and it's compounded a finite number of times, not continuously, but n is finite, and I'd like to line that up with the traditional y equals ab to the x. So here is the compound interest formula. The first thing I want to do is to disassociate the n and the t using that exponent rule I talked about a few minutes ago. If you look at what I did is I split the n and the t apart so that you would have an exponent of an exponent. Remember that when you have this situation, like we had the 2 and the 3 a minute ago, that you multiply these two things to simplify. In this case, you'd have n times t, which is how it's written over here. So this is just another rewrite of the compound interest formula. By doing this, it's going to be more obvious what the value of b is in this more complicated form. So notice that we've done a little bit of relabeling. The output of an exponential generally is y. We're calling that a for the future amount of money in your account. The start value, little a, in an exponential, we're now going to call p for the principal. If you let x be in years and represent time, x lines up with the letter t. So if you do all that, it's obvious that what's left in the compound interest formula in this form would be your b value. So my strategy in this problem, not that this is the only way you can do it, but I want to convert this big equation into y equals ab to the x, because at this point, hopefully, your teacher has shown you how to take the growth factor and convert it into a percent change. That would give you the APY, the annual percentage yield, also known as the effective rate. It's important to know that these terms are being used only in the context of money, although this formula can be used in other contexts. So for example, in my problem, my interest rate, the nominal rate, it's just a number that goes in the formula. It itself does not tell me how fast my money is growing. It's just a number that goes in the formula. You simply move the decimal to the left twice to convert it to a decimal. So notice I replaced r with 0.055. N is the number of compoundings per year. It was given that it was compounded quarterly, so that's 4 times per year. So I replaced n with 4. So now all I need to do is put this in my calculator, calculate what the b value is. Remember, that's not the percent change, that's just the growth factor. I'll need to do whatever your teacher told you how to convert the growth factor into a percent change. I'm not sure I want to show that in the video because there's so many different ways I've seen faculty do that. So I'm going to go to my calculator here, make sure it's on, type left parenthesis 1 plus, I don't know why I read it to you. You can see what I'm typing. Divide by 4, and then I want that whole base raised to the 4th power. Remember, this is just going to give me the b value, the growth factor of an exponential equation. I basically converted this larger compound interest form into y equals ab to the x, and I need not know what a is or x in this particular problem. So I know some problems give you a time value to let you know how much money or how long your money is sitting, and they give you an initial investment p, and they have your predicted future amount. But for this video, we didn't ask that question. We just want to know what percent my money is growing each year. You'll find for small percentages, like 5.5, the nominal rate, or the APR, is very close to the effective rate, or the APY. Had I chosen a large percentage here, you'd see a huge difference. But in this example, small percentage rate, small difference. So for example, the b value for this exponential equation, the equation that would model my growth, the b value would be 1.0 0.56. I'm just using my mouse to draw here, so it's going to be a little crude. My pen isn't working today. So imagine having an exponential equation where we don't really care about what the start value is, but the b is 1.056. So one way to convert this to a percent change, and this doesn't work always, is to ignore the 1, move the decimal over twice. And of course, that you can only be done if there's a 1 there. The better way to think of it is, instead of ignoring the 1, the mathematical operation that's equivalent to that is to subtract 1. So you could get away with taking your b value and subtracting 1, and then take that rate and convert it to a decimal to a percent by moving the decimal over twice, and that would be accomplished by multiplying by 100. So one way you can always convert a b value, a growth factor, into a percent change. And if t is in years, I'm assuming this is the annual percent change, so the annual percent yield, would be to take the b value, subtract 1, multiply by 100. So it turns out, even though my nominal rate was 5.5, your money is actually going to grow a little faster than that, and I'm not sure I should explain in this video because it's already getting lengthy, why that happens. Why is it that we should actually get more growth than 5.5%? Hopefully your instructor's gone over that part, or I'll make a video in the future. So my APR is 5.5%, but what actually happens, you can tell by that growth factor, is your money is actually going to grow 5.61%. I shouldn't have written it up there because that's called the APY, or the effective rate. So hopefully this video